Good day, good night, good morning, good evening, whatever time it is where you are looking at this video. Welcome to another video in our series. This time we're going to look at good day, good night, good morning, good evening, good afternoon, whatever time it is, wherever you are. Welcome to another one of our series of videos dealing with topics in the CSEC Math syllabus. In this video, we're going to deal with the difference of two squares, which is a particular type of factorization that is an offshoot of the quadratic factorization. Alright? So let us get straight into it. So remember that the general quadratic is ax squared plus bx plus c. Alright, so what happens if your bx is equal to 0, your b is equal to 0, if the coefficient of x is equal to 0, then this term will disappear. And if the constant c is negative, then this will be negative here. So what you'll in fact have will be a quadratic looking like this, ax squared minus c. And of course, if c is a perfect square, then we could express c as, let us say, k squared. Right? So you'll have a quadratic looking like this. Anytime you have a quadratic looking like that, then we have what we refer to as the difference of two squares. Alright, so to factorize a quadratic like this, factorization is simple. If I have ax squared minus k squared, then that is equal to ax minus k into ax plus k. Alright, so that's the general formula. The form in which this more generally appears in textbooks is as follows. Right? They would normally have a squared minus b squared is equal to a minus b into a plus b. Alright? Which is basically the same thing. So if you want to learn it like this, that is fine, but I went through this here just to show the progression from the original quadratic ax squared plus bx plus c, where we impose certain conditions on that. Conditions being that your coefficient b is equal to 0 and the constant c is negative, and also the constant c is a perfect square. A perfect square being, of course, a number or an entity that will give you an exact square root. So integer examples of perfect squares would include numbers like 1 and 4 and 16 and 64 and 121 and 289, 256, 400, etc., etc., etc. So anytime you hear the term perfect square, or you see it used in a textbook or an exam paper, you shouldn't have to spend too much time wondering what a perfect square is. Right? So remember, the factorization of the difference of two squares, a squared minus b squared is a minus b multiplied by a plus b. This here in blue is just the general derivation of it, right? You don't have to worry too much about remembering this. Now, of course, if you were looking at the previous videos to this, you would have recalled that this expression was part of the special expansions, where we looked at a minus b all to be squared, a plus b all to be squared, and a minus b multiplied by a plus b. So here we're looking at it from the reverse end, where we're starting off with a squared minus b squared and factorizing to get back a minus b into a plus b. Okay, so let us now go into some examples of factorizing the difference of two squares. So let us start with the simplest possible example. If they ask us to factorize x squared minus 1, alright, x squared minus 1 is simply equal to x minus 1 into x plus 1. If they ask us to factorize p squared minus 64, that is equal to p minus 8 into p plus 8. And no, it doesn't matter one bit whether you put the plus in front or the negative in front. So if you want to express x squared minus 1 as x plus 1 into x minus 1, that is perfectly fine. Similarly, if you want to express p squared minus 64 as p plus 8 into p minus 8, that too is perfectly fine. Alright, so don't waste time debating and thinking about whether to put the plus in front or the minus in front. There's absolutely no mathematical difference between the two. So let us make things a little more interesting now. If I have, let us say, 4k squared minus 64w squared, right? Look at this. Same difference of two squares, right? This will be equal to 2k minus 8w and 2k plus 8w, right? Let's think of another example. How about, let us say, 100 minus 25 p squared. Same story. 10 minus 5p into 10 plus 5p. Alright? So the difference of two squares is the easiest factorization you will ever do in your life. Alright? It's so simple. It's so simple. And it is one of the basic factorizations where quadratics are concerned. Alright? And this is not something where you should be losing marks ever at all. Alright? I'm going to show one slight variation to the question, which in showing you here, basically the idea is to prepare you for that. So once you're okay with that, then the regular difference of two squares is no problem at all. So suppose we have a question, factorize p cubed minus p. Right? Now listen to this and listen to this well. Many times in a factorization question, the question will be factorize completely. Right? Anytime you see a question that says factorize completely, that should be a hint, that should be a clue to let you know that it would be possible in the course of working the question to factorize it in a manner that would not be a complete factorization. So for example, p cubed minus p, the first line of attack is to say p into p squared minus 1. A lot of people would stop right here. Alright? Because as far as the concern is factorization. But if a question like that is worth 2 marks, be very certain that you could only get 1 maximum, because that is not the complete factorization. The complete factorization would involve recognizing p squared minus 1 as the difference of two squares. So that the next line here would be p into p minus 1 into p plus 1. That is a complete factorization. That is what will get you full marks in a question like this. So be prepared also, apart from having to just recognize the general difference of two squares, be prepared also for the fact that it may not be immediately apparent from the first line. Right? The first line may involve your regular typical factorization, as in this case here, where we took the p out as the common factor. But having done that, you realize that you now have in the brackets a difference of two squares, which would then mean that you have to factorize p into p minus 1 into p plus 1. So before we go, There's one more I want to show you. Alright? Consider the following. If they ask you to factorize 2p cubed minus 8p. Alright? So the first thing you do is take 2p out as a common factor. So you get 2p into p squared minus 4. Alright? And then again, just as upstairs here in black, p squared minus 4 is different to 2 squared, so this would be 2p into p minus 2, p minus 2 into p plus 2. And that is it. So I'll give you 2 examples in the video, right? Just to extend the discussion a little bit. It's not just about x squared minus 1 or w squared minus 64 or 25 minus p squared or 1 minus k squared. No. Sometimes the difference of 2 squared is buried within a regular looking factorization, and in the course of factorizing you have to pull it out, and once you pull it out you still have a duty to recognize it, and of course having recognized it you factorize it. Okay, that's about it. There isn't much else that we need to say about the difference of 2 squares. So that's it. Go right ahead now and do it.